Vivekananda Sharma Memorial RV College presents Video Lectures, an ISR initiative. SSMRV College, one of the premier institutes run by the prestigious RV group of institutions, has come up with a unique initiative to encourage students at the time of this unforeseen medical emergency caused by corona outbreak. As a socially responsible institution, we would like to connect academically with students to make good the losses caused. In this connection, I, Salma, Assistant Professor, Department of Commerce, has posted a video on the subject Methods and Techniques for Business Data Analysis, and the topic is Logarithms Part 2. Please watch video till the end and like, share with your peer groups and subscribe to our YouTube channel. Thank you. Our topic, indices and logarithm. Indices is already covered in the previous video, that is part 1. Hope you have watched that. If not, please watch that video to understand about the concept of indices. Now in this video, we'll be learning about logarithms. First, let us look at the introduction. The logarithm is the inverse function to exponentiation. The logarithm of a given number x is the exponent to which another fixed number, which is the base, must be raised to produce that number. In simpler words, or in other words, the logarithm of a number, if the logarithm of any number given to a base, it is the index or the power to which that base must be raised to produce the number. Now let us look in the form of a simple example. If a is a positive real number, here the condition is a should be a positive real number other than 1, such that a to the power x is equal to n. This is in the indices form. Then x is called the logarithm of n to the base a. Symbolically, it is expressed as log n to the base a will be equal to x. As you can see here, a to the power x is equal to n. When it is converted into logarithm form, it becomes log n to the base a equal to x. Here, the exponent becomes the final answer, and this number you are going to log to the base of this particular number. Here we have a numerical example. For example, 2 to the power 4 is equal to 16. It is in the indices form. 2 to the power 4 is equal to 16. This will be converted to logarithm in this form, which is read as logarithm of 16 to the base 2 is 4. So as you can observe here, this exponent 4 will become the answer. That is the final answer. So log 16. This answer here is going to be logged to the base of this particular number. Kindly observe this pattern, which will be used in all the problem solving. Here similar type of example, 10 to the power 2 is equal to 100, which will be written in the form of log 100 to the base 10 will be equal to 2. Now let us look at the laws of logarithm. Here we have the first law, which is log mn to the base a will be equal to log m base a plus log n to the base a. It can also be expressed in this form, which is nothing but the inverse form. Log m to the base a plus log n to the base a is nothing but log mn to the base a. Here, logarithm of the product of two or more numbers to any base except 0 and 1. This is important. The base should not be 0 or 1 is equal to the sum of logarithms of the numbers to the same base. As you can see here, this is the product of two terms, m and n. This, whenever it is given in this form, the product form, then you can split by using the addition operation. So now points to be noted. The logs must have the same base. If not, the law is not applicable. For example, here we have taken a similar example where you have log 8 to the base 5, log 2 to the base 3. You have the addition function, but as you can see, the bases are different. That is why it will not be equal to either of the two, log 16 to the base 5 or log 16 to the base 3. You cannot choose any one of the base because the bases have to be the same. Next point, the sign in between the two terms must be of addition and not multiplication. Here you can understand by using a simple example. Log 5 to the base 2 plus log 10 to the base 2. Here you can see the bases are the same and in between there is the addition operation. So that can be written as log 50. 50 is nothing but product of 5 and 10 to the base 2. But when you have log 5 to the base 2 into log 10 to the base 2, here you have the multiplication operation. So you cannot write this as log 50 to the base 2. You can see the simple difference here. The addition operation will let this law be applicable. Whenever it is multiplication, this particular law is not applicable. So if you understand these laws, it will be easier for you to solve all the problems. Now let us look at the second law. This is the division or quotient law, where log m by n to the base a. As you can see here, we have the division function can be written as log m to the base a minus log n to the base a. Whenever you have the division function, you can split the terms by using the subtraction or the negative sign. Logarithm of a quotient of two numbers to any base except 0 and 1. The base should not be 0 or 1. Is the difference of logarithms to the same base. Here we are taking the difference. A small note, log 1 by n to the base a can be written as log 1 to the base a minus log n to the base a. We are using the same law here and splitting the two terms. Here log 1 will become 0, which you will see in the further explanation. That will remain with log n base a with a negative sign. Moving on to the third law, that is log m to the power n. Here you have one power here or index to the base a. Can be written as n log m to the base a. Here whatever the index we are taking, when you are going to convert it into logarithm, you can take this n outside. Instead of writing it as the index, you can use it as a product that can be multiplied with this number. Logarithm of the number to any base raised to a power is equal to the index of the power. This index of the power multiplied by the logarithm of the number of the same base. That means you are going to multiply the power with the logarithm of that number. Moving on to the fourth law. Log m to the base a can also be written as log m to the base b divided by log a to the base b. Logarithm of m to the base a is the quotient of logarithm of m to the base b and the logarithm of a to the base b. Here base b is any other base other than base a. That means whenever you have this base a, this can be taken in the denominator by using a new base b that is common to both the terms. Now simple points that you have to remember which will help you in solving your problems. Here you can see logarithm of any quantity to the same base is always unity, that means 1. Here you can see this. This is in the form of index. 10 raised to the power 1 will be equal to 10. As already discussed, any number raised to the power 1 will always be that number. Now when you are expressing that in the form of log 10 to the base 10 will always be 1. Any number which you have the base, that same number, then your answer will be 1. Here you can see log 2 to the base 2 is 1. This in general form can be written as log a to the base a is 1. Next common point, the logarithm of 1 to any base is 0 only. This is also very important while solving your problems. Any number which has, wherever the power raised is 0, your answer is 1. This is a rule of indices. But when you come to logarithm, you can see here log 1 to the base 10 is 0. Log 1 to the base 2 is 0. Here what is common is you are taking the logarithm of 1. Base can be any number. But whenever you have log of 1, the answer you will get is 0. This you can easily substitute whenever you are solving your problems. That is why it is important to remember. Whenever no base is mentioned in your problems, when no base is given, it is implied that the base is 10. If the base is 10, it should be treated as common logarithm and you can solve the problem without any confusion. Whenever the base is not given, just assume it to be 10 and the same base in all the terms. These laws are very important for you to solve the problems, which you will be seeing in further slides, where you will understand the applicability of all these laws in practical problems. Now here we have few problems based on the laws and based on few basic principles. This is what we have already seen. Let us just have a quick revision. A to the power x is equal to n. This is in the indices form. Then x is called the logarithm. The exponent x is called the logarithm of n, of this number n to base a. Here this number becomes the base. So symbolically it is expressed as log of n to the base a will be x. You can see these numbers, how they have been expressed in the form of logarithm. The same pattern will be applicable in all the problems whenever you are converting index to logarithm or logarithm to index. Have a proper understanding of this term. A will become the base here. The power x will become your final answer. And here whatever you have n, that you are going to take the log of that particular number n. Now let us look at few example problems where you have stayed in logarithm form. These numbers are given in the form of indices. So as per the question, you have to convert it into logarithm forms. You can see the first example, 2 to the power 4 is equal to 16, which is in the form of a to the power x is equal to n. So now while converting it to logarithm, you are going to take log of 16. That is this number, log of 16 to the base of this number, which is 2 here. Log of 16 to the base 2 is equal to 4. The exponent here becomes the final answer. The same way in the second example, you have 125 raised to the power 2 by 3 is equal to 0.04. So you will take log of 0.04, the base becomes 125 and your answer becomes 2 by 3. So log of 0.04 to the base 125 is 2 by 3. Next example, 3 raised to the power minus 5. As you can see, you have a negative value here is equal to 1 by 243. Can be expressed as log of this number, that is log of 1 by 243 to the base 3 will be equal to minus 5. Next example, 5 root 5 whole raised to the power 2 is equal to 125. So now this number becomes your base. Log 125 5 root 5 will be equal to 2. Observe in all the problems, the exponents here have become your final answer. Your final answer is going to be taken for logarithms, and your number here, whatever is expressed as a here in the formula, will be taken as basis in all the examples. So this is a standard form which you have to follow while converting indices to logarithm in all the problems. Now let us move on to the second type of examples where you are given logarithm form and you have to convert it into index form. It is the reverse of what we have done in the first example. Let us look at the first thing. Log 1024 base 4 is 5. This is your question given. Now you have to convert it into index form. So as you have already seen, this 1024 will become your final answer. 4 is your base, which becomes your main question here, that is in the form of a to the power x. So your a is 4 here, power x is 5. So 4 to the power 5 is 1024. Next example, log of 1 by 256 base 2 is minus 8. As soon as you see this problem, it is very effective if you convert it into the standard form. If you write it in this way, log n to the base a is equal to x, then you will know what is a, what is n, and what is x. So here in this example, you can see a is 2, n is 1 by 256, and x is minus 8. So now while converting, you are converting to this form, a to the power x is equal to n. So as you had already converted here, a is 2, so you will write 2 to the power x. What was your x here? It was minus 8. So 2 to the power minus 8 is your a to the power x, remaining with n, which was 1 by 256, so is equal to 1 by 256. It is highly suggested that you convert your question into the standard form and substitute these terms in your index form. Similar example here, you have the decimal numbers here. Log 0.0001 to the base 10 is equal to 1 by 4, which is given in your index form as 10 to the power 1 by 4 is equal to 0.0001. So I hope you have understood how to do the conversion from log to index and index to log. This is important when you are solving your bigger problems. Moving on to a simple problem. Find the value of log 1024 to the base 2. This is familiar to you as you have already seen these numbers in your example. We have taken the same example so that you will know how to process this log number. So first you are going to take this entire term log 1024 to the base 2 and substitute it to x. Let this log number be x. So now 1024, you are going to take it as 2 to the power x. You are converting log to index here in this same form again. So 2 to the power x is equal to 1024, and moving on with 2 to the power x is equal to this 1024 can be written as 2 to the power 10 in the form of index. So now as you can see, 2 and 2, which is the same, that means x is equal to 10. This is very simple to understand. When you have the same basis, that means your exponents are same. As per exponents law, x is equal to 10. So because your x was substituted to your question, that is log 1024 to the base 2. So now log 1024 to the base 2 is equal to 10. Moving on to the next problem. Evaluate log 125 to the base 5 root 5. Again, this question is already been considered in the example problem, so that you can be more familiar with these type of numbers. Now this entire problem again is substituted to x. Let log 125 to the base 5 root 5 be x. So you are going to write this in the form of index. 5 root 5 whole power x, here this becomes your power, is equal to 125. You are converting it to index form. Moving ahead, 5 into 5 to the power 1 by 2. 1 by 2 because here you have the square root, that is your power 1 by 2. You are just writing this in the form of power 1 by 2. Whenever you have the square root here, you are going to substitute it 1 by 2 in the exponent. Whole power of x as it is, and 125 can be expressed as 5 to the power 3 in index form. Now in the next step you have, because this is being multiplied, as you have already seen in the indices law of multiplication, you can add these two exponents here. Because nothing is mentioned, that means 5 to the raised 1. Whenever you have nothing mentioned to any number, that has an invisible power of 1 always. So that is being added here. 5 to the power 1 plus 1 by 2 whole power of x is equal to 5 to the power 3. This when taken as LCM, this because this is a fraction, 1 plus 1 by 2, that is simple LCM which you take, which will come to 2 plus 1 by 2 to the power of x, 5 to the power 3. After solving the LCM, you will get 5 to the power 3 by 2 whole power x, which is equal to 5 to the power 3. Now you are just opening this bracket and multiplying these two terms, 3 by 2 and x. So you will get 3x by 2 is equal to 5 to the power 3. Now because you have 5 and 5 in the base, you can leave this base and only consider the exponents. That is 3x by 2 is equal to 3. And because you are going to transpose this here, it becomes 6. 3x is equal to 6. X is equal to 6 by 3 because this comes here in the denominator. And your final answer is x is equal to 2. Now because you have found x is equal to 2, that means you have found log 125 to the base 5 root 5 is equal to 2. Moving on to the next problem, find the value of x if log 4 to the base x is 0.4. This is a new problem we have given here, that is, you have to find the value of x. But these terms have been taken again from your example problem. So log of 4 to the base x is equal to 0.4. Now because you should find the value of x, here the base is not given. It is missing. That means you have to find the value of the base. So now let us write this as log 4 to the base x is equal to, instead of writing 0.4, we are converting it to decimal, which is given here in the side for your understanding. 0.4 can be written as 4 by 10. We are writing that here. So log 4 to the base x, as we can see here, 4 and 10 gets cancelled, so we get 2 by 5. Now you are converting it to index form. That is, your base x to the power of this number 2 by 5 is equal to 4. Now because you have to cancel this exponent 2 by 5, you are going to take the inverse 5 by 2 on both the sides. Because you are taking it on both the sides, so it has no effect and it's not wrong to take it on both the sides. So x to the power 2 by 5 whole raised to the power 5 by 2, as we have mentioned, even for 4 on LHS and RHS. That is, your left hand side and right hand side, you are taking the power 5 by 2. So this, because it's 2 by 5 into 5 by 2, it gets cancelled here and you will remain with x, and this will remain as it is, 4 to the power 5 by 2. Because here you have 2 in the denominator, you can write it in the form of square root 4 to the power 5. Whenever you have such a term, you can simplify it to the following using the square root or cube root, whatever is given in the denominator. As here you have 2, that is why we are taking 2 root, or you can call it a square root of 4 to the power 5. Now under the square, we are just expanding this 4 to the power 5. 4 to the power 5, as already discussed, means 4 multiplied by itself 5 times. Now in this, as you know, it is a square root. 4 into 4 is 16, which will give you 4 again, because you are going to square it. I mean, you are going to take the root of 4 into 4 is 4. Again, of these two numbers, 4 into 4 is 16, and the root of this number will be 4, and root of this single 4 will be 2. That is how we'll end up with 4 into 4 into 2, which is 32. So your x is 32. That is what has been given in the question. To find the value of x, that is your base, x is 32. Now we have few more problems here. This is the law which we have already discussed. A quick revision on this. If the base is not mentioned in logarithms, then assume that the base is same everywhere. As soon as you see the problem, you might be confused if the base is not mentioned, and you might get stuck to solve the problem further. So this rule is very important for you to remember. If the base is not mentioned, just assume that the base is same in all the terms and go ahead with the problem. So let us solve few problems on this particular law so that it is more clear for you. Expand log 4 plus 2 log 3. As you can see in this question, bases are not given. So that means you are going to assume whatever the base is, it is same, and you can proceed. So here log 4 plus 2 log 3 is written as log 4 plus, here this 2 will go to the power. Because of this rule, log m to the power n can be written as n log m. So n log m is 2 log 3. So that is going to the power here. That is 3 square. So now you are going to write, because of multiplication law, that is log 4 plus log 3 to the power 2. That means log a plus log b can be written as log a b. That is the product of the two terms. 3 square is substituted as 9 here. So log 4 into 9, that is log 36. This is the simplest form, so leave it here. Next problem, expand 3 log 2 minus 2 log 3. Again, no bases are given. Assume the bases are same. Here 3 log 2 can be written as log 2 to the power 3, because of the law log m to the power n is log n log m. Okay, the same law is taken here. This 2, which is the product, will be taken in the exponent, log 3 to the power 2. So 2 to the power 3 is nothing but 8. So log 8, 3 square is 9 minus log 9. So here, because of the division or quotient law, that is log m by log n can be written as log m minus n. So these two, you are going to write it in log 8 by n because of the quotient law. Next problem, solve log 36. Only log 36 is given. That means you have to take it to the simplest form, simplify. Log 36 can be written as log, this is 2 to the power 2, that is 4, and 3 square is 9. So 4 into 9, it means 4 9s are 36. So 2 to the power 2 and 3 to the power 2. When you have this term, you can simplify this further, taking log 2 to the power 2. This term plus log 3 to the power 2. Because of the multiplication function, you are going to split this by using the addition operation. That is log AB is equal to log A plus log B. So finally, After this, you can take these exponents as a product of the two terms, 2 log 2, and this 2 again comes out 2 log 3. This is the simplest form of this question. Solve for x if log x to the base 10 is 2. Here again you have to solve for x. That means you have to find the value of x in this given question. So log x to the base 10 is 2, which can be converted to index form. That is, your base is taken here, 10 to the power 2 is equal to x. So that means your x is 10 to the power 2 is nothing but 100. So you derive it, x is equal to 100. So find the value of log 2 plus log 3 plus log 4. These type of questions, if you see, you might get confused, but it has just one line answer, and only if you know the law, that is log A plus log B plus log C, then you will know how to solve this question. That is simple. You have to take the product of all these terms because you have addition in between. So log 2 into 3 into 4, that is log 24. This is very simple problem, but applicability of law is important. Moving on, simplify log 15 to the power 3 minus log 3 to the power 5. Here you are going to take, because of this exponent, you are going to take it as a product, 3 log 15. Again, this exponent 5 will be taken as product, 5 log 3. So here 3 log 15 is split as 3 into 5, 15. This is as it is. So now what you can do is, because this is in the form of log m into n, you are splitting it as log m plus log n. This is the split term for this one particular term. 3 log 3 plus 3 log 5 minus, as it is, 5 log 3. So to proceed, as you can see, you have common bases here, that is log 3 and log 3. So you can proceed to operate these two, that is 3 minus 5, which comes to minus 2. This 3 log 5 is taken as it is here, but these two are getting operated and coming to minus 2 log 3. So now you cannot solve this further because you have different numbers here. So convert it into the form of log 5 to the power 3, log 3 to the power of this 2, that can be written as log 5 cube by 3 square. Because this is the subtraction here, so you are going to write it as log A by B. That can be written as log 5 cube is 125 and 3 square is 9. So log 125 by 9 is your final answer. Next question. Here you have proved that log 64 to the base 3 divided by log 8 to the base n is equal to 4. So here you can see this whole thing is your LHS, nothing but your left hand side, and your 4 is RHS. So you have to prove that these two are equal. In such type of problems, you will take first only the LHS or the left hand side. So here we have taken the change of base law, which we have already discussed while explaining about the laws of logarithms. So we are taking log 3, log 64 to the base 3 divided by log 8 to the base 9. Here what we are doing is we are taking the bases different. That is, this base you are taking as a separate term because of change of base law. Log 64 by log 3. Again, this term is getting split as log 8 by log 9. The division symbol remains the same. Now 64 is written as 2 to the power 6 divided by this 3, log 3 remains the same, log 2 to the power 3. 8 is written as 2 to the power 3. Now because of this exponent form, what you can do is you can take this 6 out by giving it as a product. 6 log 2, the same thing here, 3 log 2. Now once you come to this point, what you can do is take this term as it is, 6 log 2 by 6 log 3, and this term because you have division symbol, that is your simple fraction operation which we do, we take it as multiplication and we will take the reciprocal of this term. Instead of 3 log 2 by 2 log 3, we are taking the denominator as the numerator, that is 2 log 3 by 3 log 2, because we are converting it into multiplication operation. So as you can see here, log 3 and this log 3 gets cancelled. Because it is multiplication, you can cancel. No other operation you can cancel these terms. And here log 2 get cancelled, and when you solve 3 and 6, you land up with this 2, and 3 and 6 if you solve, you will get 2, because 3 ones are and 3, that is 3 twos are 6. So you will come with 2 and this 2. 2 into 2 is 4. That is what was given in your RHS. So now you have got your answer as RHS. That means your left hand side is equal to the RHS and hence it is proved. Let us look at few more problems. Now what we have seen in the previous slides is different from what we are going to see in these problems. I have tried to pick problems which have different laws so that you will understand the applicability of all laws, and in certain problems there are also chances where multiple laws are being applied at a time. And the main thing is you are going to learn about the link between indices and logarithm, because both the concepts are interconnected. Without indices you cannot solve logarithm. Without logarithm you cannot solve indices. So both are interconnected, and we have also looked at all the operations like addition, subtraction, division, multiplication. We are seeing at all the different types of operations, different types of problems, and the fraction, decimal, all these differences we are seeing, so that you can practice all these problems again and again to make it perfect and you can solve all the problems. Previous and the current. Each step you have to observe and see how the previous step is different from the next step, and you have to observe how each step is being carried on to arrive at the final answer. And another thing which is important is your each step carries marks, so you have to mention all the steps to come to the final answer. Now let us look at few more problems. Prove that. Here again you have proving, that means you have two sides, your left hand side and right hand side. So in your left hand side you have 6 log 2 plus 2 log 6 is being divided by 4 log 2 plus log 27 minus 2 log 3. This should be proved equal to your right hand side where you have only 2. Now let us consider this left hand side. So you are taking it as it is in the question. Now in your next step, the only difference you will see is here 6 log 2 is written as it is 2 log. Instead of writing 6, we are taking it as 3 into 2. In your denominator 4 log 2 plus, instead of log 27, we have substituted it to log 3 to the power 3. Whenever you see such things, understand 27. When you have to arrive at 27, you have to multiply 3 times. That is how you are going to substitute these powers. Minus 2 log 3 as it is. Now in your next step, 6 log 2 is taken as it is, but here you can see you have log m into n, which can be split using the addition operation as log m, that is 2 log 3 plus log n 2 log 2. This 2 log is applicable to both the terms and split by using addition operation. In your denominator you have 4 log 2 plus this power can be taken out as product 3 log 3 minus 2 log 3. Now coming to the next step, as you can see you have two common terms, that is in your numerator log 2 log 2. So you can take these two together, that is 6 plus 2. You are taking this 6 and 2 together in the bracket and log 2 here common. So 6 plus 2 log 2 plus 2 log 3 as it is. In the denominator again you have two terms which are common with log 3. So 4 log 2 as it is, and take this in bracket 3 minus 2 log 3. So when you solve this, you get 8 log 2 plus 2 log 3 by 4 log 2 plus 3 minus 2 is 1. So no need to mention 1 here. You can directly take log 3. Now when you see this, you can easily come to know there is something common in all these terms, which is 2. So what you will do is you will take 2 out from the numerator only. So if you take 2 common, you will remain with, instead of 8, because you have taken 2 common, so you will remain with 4 log 2, because 2 into 4 will give you 8, and you have taken 2 common, so this 2 is already taken out, so only log 3. So now as you can observe, 2 is out. Here you have 4 log 2 plus log 3, again here 4 log 2 plus log 3. So these two terms can be cancelled, so you remain with only 2. That is your right hand side that was given in your question. So now you have proved that your left hand side is equal to right hand side. This is how you are going to proceed with the problem. You have to practice along with all the steps, and even the minute adjustments whatever we have done should be practiced, so that you will get used to it and you will solve the problem correctly without missing on any steps. Okay, now let us move on to the next problem. Prove that log 3 to the base 2 into log 2 to the base 7 into log 7 to the base 3 is equal to 1. Again here you have the LHS and RHS. RHS is 1, so we'll only take the LHS which we have to prove. So we are taking the LHS. Now this here, whenever you have such a term, what you can do is you can substitute it to this format as fractions by using the change of base law. So log 3 by this power can be taken as denominator. This base can be taken as denominator. So log 3 by log 2. Again log 2, this base we are taking as separate denominator, log 7 into log 7 by log 3. As you can see this, it's very simple to understand. Log 7, because you have multiplication operation in between, so you can easily cancel log 2 and log 2 in the numerator, log 3 in here numerator, and log 3 in the denominator, log 7 in denominator, and this log 7 in the numerator. So the only thing to remain is 1, which was given as your RHS. Hence this problem is proved. Now moving on to another problem which has bases. Till now we have been looking at few problems which didn't have base. Now we'll see whenever you have base how you can solve the problems. Log 2 to the base 4, log 2 to the base 8 minus log 2 to the base 16. As you can observe in these problems, whatever we have given, the bases are different. Hence you cannot proceed with the problem using the other laws. The only law applicable at this stage will be your change of base law. So that's why you are taking log 2 by this base will become the denominator, log 4, plus as it is log 2 by log 8, log 2 by log 16. So coming to the next step, all the numerators remain the same here as it is log 2. In the denominator, instead of 4 you can write 2 square, that is 4, and instead of 8 you are writing it as 2 to the power 3, and log 16 you are writing as 2 to the power 4. That means 2 multiplied by itself 4 times will give you 16. That is what is meant by 2 to the power 4. Coming to the next step, what you can do is again the numerators remain the same because that is the simplest form which you can convert it to. In the denominator you have log 2 to the power 2. This 2 can be used as the product, that is 2 log 2. Same will be applicable to these two terms. You will take this as 3 log 2 and this log 2 to the power 4 as 4 log 2. Now you can observe you have log 2 and log 2 in all the terms in the numerator as well as denominator. So these all can get cancelled, but only within itself and not with inter terms, because you have plus and minus sign in between. So only the numerator and denominator will get cancelled. So you will remain with 1 by 2. Nothing is mentioned. It means you have 1 in the numerator. This is very important for you to consider. Just because you cancel log 2 and log 2 doesn't mean you remain with 2. 2 is in the denominator. That means you have 1 in the numerator, which is absent, but you have to consider. It is invisible number. So 1 by 2, and here you have 1 by 3 minus 1 by 4. You are taking the LCM, that is your basic fraction solving. 2, 3 and 4. When you take the LCM, you get 12. To put it into a common denominator, you will multiply this with 6 and this one with 4 and this one with 3 to come to 12. So you have 6 plus 4 minus 3, and when you solve, you get this 7 by 12. So that was simplify this entire term which you have done, and you have concluded with 7 by 12. Moving on to the next problem, we have find the value of 6 log 1000 to the base 10, and in the denominator we have 3 log 100 to the base 10. We have taken this in the same form. Now what you can do is this 1000 can be written as 10 to the power 3. 10 multiplied by 10 3 times, and 100 can be written as 10 to the power 2. So now what we can do is this 3 can be taken as the product again, because this is in the exponent form. So you are going to take 6 into this exponent out, 6 into 3, and in the denominator 3 is already there. You are taking this exponent here, 3 into 2. Log 10 to the base 10 remains the same. So when coming to the next step, 6 into 3 and 3 into 2 remains the same. Log 10 to the base 10 is 1. Log 10 to the base 10 is 1. As we have already discussed in the points to be remembered, log of any quantity to the same base is always 1. So that is why we have taken 1 here. So when you solve all these things, you will arrive at the final answer of 3. So this big sum will give you the answer as conclusion as only 3. That depends on how you apply the laws and how you follow each step to arrive at the final and the simplest form of this logarithm problem. Now we have few more problems. These problems are slightly different because they have a little more steps to be solved, and the procedure is quite lengthy than the previous problems we have seen. But these are simple, and only if you know the laws well, you can solve it very easily. Now let us look at the problem. Here you have simplify log 24 plus log 3 minus log 18 divided by log 16 plus log 6 minus log 24. As you can observe, here you don't have any bases mentioned. So that means you have a common base and you can just proceed without the bases. So now we are taking the question here and writing this in the next step as, instead of 24, we are splitting it as 8 into 3. And this log 3 is taken same, minus, instead of writing log 18, what we'll do is we'll write log 9 into 2. This is because of your product or multiplication law. Log 16, this 16 can be written as log 2 to the power 4. That is 2 multiplied by 2, 4 times will give you 16. And log 6, 6 is split as 3 into 2. Again 24 is split as 8 into 3. In the next step, we take log 8. Here you have, observe this pattern. You can easily understand that it is in the form of log m into n, which you can split as log m, that is log 8, plus log n, that is your log 3. So you are splitting this one single term into two terms using the addition operation. Moving on with this term, you are taking as it is log 3. Again the same rule applied here. Take this minus out because here you have a negative sign. So be careful in this step so that you don't go wrong. Take minus out and take this in the bracket. So you remember to change the sign in the next step. If you forget the bracket, you might miss this sign that has to be changed. So you are taking log 9 plus log 2, splitting these two terms. The same way here, log 2 to the power 4. This 4 as the exponent can be taken out as the product, 4 log 2. Same thing, log mn can be written as log m plus log n, log 3 plus log 2. Minus, again take the negative sign outside the bracket, log 8 plus log 3. Moving on to the next step, we see here this 8 can be expressed in the simplest form by writing 2 to the power 3. 2 multiplied by itself 3 times to give you 8 plus log 3 plus log 3, same way. Here what you are doing is you are just removing this bracket and you are changing the sign. Minus into plus will give you minus. So minus log, instead of 9 you will take it as 3 square. That will give you 9. And here you have to be careful. Minus into plus is minus. If you go wrong here, your further simplification will go wrong. So be careful with this step. Minus into plus minus log 2. In the denominator, 4 log 2 as it is, log 3 as it is, log 2 as it is. Only thing you are doing is opening this bracket to change the sign. Minus log, instead of 8, we'll take it as 2 to the power 3. Minus into plus minus log 3. Next step we'll see is log 2 to the power 3. So you're taking this exponent 3 outside as the product, 3 log 2 plus log 3 plus log 3 minus 3 square. You can split this as 2 log 3 minus log 2. In the denominator we have, the only difference we see here is this particular term log 2 to the power 3. This 3 you can write as 3 log 2. That is the only difference of denominator. In the next step, what we can do is we can take the like terms together. 3 log 2, then search for any other term which has log 2. So you have 3 log 2 and minus log 2, write it together so that it's easier for you to solve. Then put these log 3's together, log 3 plus log 3 minus 2 log 3. The same thing has to be done in the denominator. Take the like terms together. 4 log 2 plus log 2, another term minus 3 log 2. So all these 3 terms have log 2 as common. So take it together. The remaining plus log 3 minus log 3. When you solve this, you can see here 3 log 2 minus log 2. That means 3 minus 1 here, because you have the invisible number 1 always accompanying with logarithm. So 3 minus 1 will give you 2 log 2. Here you have 1 log 3 plus 1 log 3, which will give you 2 log 3. Again you have minus 2 log 3. So 2 log 3 together minus 2 log 3 gets cancelled. So this entire term of log 3 is gone. You remain in 2 log 2 in the numerator. Let us look at the denominator. You have 4 log 2 plus 1 here. So 1 log 2, that is 5 log 2 minus 3 log 2. So 5 minus 3 will give you 2. So 2 log 2. After solving 4 plus 1, 5 minus 3 gives you 2 log 2 as it is. As you can see this here, log 3 has only 2 terms, plus log 3 minus log 3. So you get 0, or it is getting cancelled here. So the only thing remaining here is in the numerator you have 2 log 2, in the denominator you have 2 log 2, which gets cancelled and you remain with 1. So this is the simplest form of this huge problem which you can see here. Each step is very important for you to practice and solve each step so you understand the differences in each step clearly. Let us look at another problem which has fractions in it. So we'll see this also, which has mixed fractions. So you will understand how to solve these kinds of problem as well. Log 75 by 16 minus 2 log of 5 by 9 plus log of 32 by 243. So So what we'll do is we'll take this as it is. Instead of writing 2 log 5 by 9, we'll take 5 by 9, logarithm of 5 by 9 to the power 2. This can be taken as exponent 2 plus log 32 by 243. Now after solving this, what we'll just do is 5 square and 9 square. If you open this, you will get 25. 5 square is 25, 9 square is 81. So log 25 by 81 is the only difference in this step. Now, one important thing for you to note here is only one term has a negative sign. So this is stopping you from applying the multiplication law. So what you can do is you can convert this minus into plus. So how you will do is it? Log 25 by 81, which has a negative sign, can be written as plus log 81 by 25. You will just take the reciprocal of this fraction to convert this negative into positive. So now what you get is log 75 by 16 plus log 81 by 25. You are taking the reciprocal. Note this step clearly. Plus this log 32 by 243. Now because you have taken the reciprocal, you have all the terms as plus. So now because you have plus, now you can easily apply the multiplication law, which is your log of a plus b plus c can be written as log a into b into c. You can take the product of the terms. So you will take 75 by 16 into, because you have taken the reciprocal, so write 81 by 25 very carefully plus 32 by 243. This will have multiplication sign as you are taking the product and not addition. So log of this product. When you solve this entire thing, you will remain with 2. So log 2. This is your simplest form. Because they have asked you to simplify this entire problem into the simplest form, this is the simplest form and you can leave the problem to this term log 2. All the problems discussed and also the laws of logarithms. So this is what is important in your chapter of logarithms. Now what we will suggest you is that you have to practice all the problems step by step to understand how it is solved and what are the laws to be applied in each step. Don't just look at the problem or read the problem and think that you have understood. Only when you solve the problem, you will understand how the laws have to be applied. So, it is very important for you to sit and practice the problems as much as possible to understand it clearly. Thank you for watching.